Alright, so today we are covering 1-5 angle relationships. We have some new vocabulary words per usual. Our first term is adjacent angles. So adjacent angles are angles that are connected by one ray. So they share one ray. So they may look like this, and by they may look like this, I mean they will look like this 90% of the time. So it's like one big angle, so that black angle is a big one, and then it's cut by that blue ray, which gives us two individual angles here. So if I were to label this A, B, C, D, we would say angle AB, not ABC, angle ABD is adjacent to angle DBC. So they're just two angles that share one ray or share a common side. A linear pair would be a pair of adjacent angles. So that would be a pair of adjacent angles that when you add up their measure, they equal 180. So they're, oh, that was a beautiful line there. So it would be something like this, where if I say angle A and angle B, so they add up to equal 180 degrees, which we can see because when connected, they make a straight line. So that would be a linear pair, two angles that combine to make a straight line. Vertical angles are when you have a pair of intersecting lines, like that. Then our vertical angles would be like these two. So they're the ones straight across from each other. And the important thing about vertical angles is that they are always equal. So they have the same angle measure every single time. Complementary angles are angles that add up. When you add their degrees, they equal 90 degrees. Supplementary angles are angles where when you add them up, they equal 180 degrees. So complementary and supplementary, you often see grouped together because they're very similar. Perpendicular it's typically perpendicular lines, but that just means that where they cross or intersect, it's 90 degrees, which is usually signified by this little box in the corner. And if we have two lines that are intersecting and are perpendicular, then it's not just one of these angles that's 90. They'll only show the one box, but in fact, all of these angles are 90 degrees then. All right, so here are some additional definitions and pictures that you can put in your notes. If you want to pause the video here, feel free. I'm going to continue to move on. So our first problem. Name an angle pair that satisfies the condition two angles that form a linear pair. So if we go back to our first vocabulary page, we know that a linear pair are two angles that add up to equal 90 degrees. Or not 90, 180 degrees. So right here, I'm going to take, and I'm going to go across this line here. So that's going to be my straight line. And then the angle I'm going to choose is connecting right here. But my points for that's an I right there. So I would say angle P IQ and angle QIS form a linear pair. So if you notice, the Q and the I are similar in these because they are that ray. They form the ray that is shared on this linear pair. Name an angle pair that satisfies the condition two acute vertical angles. So our vertical angles are, well, so this is one set of vertical angles. This is another set because they are straight across from each other through that intersection point. And then this is our third pair of vertical angles. So I'm going to go ahead, I'm going to choose this set here because I believe they are the most acute. It doesn't matter, any acute will do, but I'm going for the most acute, the smallest angle. So my angles are PIU and angle RIS. Notice how these only share the one similar point that is the vertex, that I point. Because whenever we have vertical angles, they only have that one common point, or else they would be adjacent, not vertical. So now we're supposed to name two adjacent angles whose sum is less than 90 degrees. So our adjacent angles have to share one ray together. So let's just start from A and work our way through. So CAD, and DAE. Okay, so when we add these up, we get more than 90 degrees. So that one's out. So nix that. That one's done. Now if we go for FAE, and FAN, if we add those together, we get 85 degrees. So this one satisfies it, but let's just check on our other options just to make sure. So we have angle CAB and angle NAB. Well, NAB is 90 degrees already, so we know that one can't work. So that one's a no-go. Angle BAD, let's get the correct writing utensil, BAD, and angle DAC. Okay, so this isn't even a pair of adjacent angles because they share more. BAD. Well, so these aren't adjacent because this ray AC falls in the middle of our first angle BAD. So for them to be adjacent, we can't have any part of it in the middle of one of the angles. So they must only share that the one ray. They can't share. So BAD encompasses this whole area in here, and then DAC encompasses this area here. And so we have this overlapping, this overlapping blue and yellow here, and we can't have that. So that one's a no-go as well. So our answer has to be B. Now we're supposed to name two acute vertical angles. So once again, let's go through and name our vertical angles. So we have these, the 55s, we have the 30s, and then we have our 95s here. are all sets of vertical angles. So let's look at, and in our wording here, we have to have two acute vertical angles. So BAN is not acute, so we can eliminate that right off the bat. BAD and BAN again. So BAN is not acute, even though it looks like it is based on the drawing. So that one's a no-go as well. Now what about BAC and CAE? So those are not vertical angles. So that one does not work, which means it has to be D. But let's double check just to make sure. We have FAN and DAC. So those are vertical angles. They are acute. So that is our answer. Find the measures of two complementary angles if one angle, so angle 1 equals 6 degrees less than 5 times the measure of the other. So our other angle I'm going to call x. So 5x minus 6 equals one of our angles. And then our second angle is just going to be x. And now we know angle 1 plus angle 2 equals 90 degrees because it's complementary. So what I'm going to do here is I'm going to substitute in for angle 1. I'm going to substitute in this whole bit here. So I'm going to say 5x minus 6 plus all of angle 2, which is just x, plus x is going to equal 90 degrees. So if I combine like terms, I'm left with 6x minus 6 equals 90. Then I'm going to add 6 to both sides to solve this equation. So I have 6x equals 96. And then I divide by 6, and I get x equals let's see, mental math only works if your brain works. X equals 16. So one of my angles has to be 16. So right off the bat, I'm saying it's C, but I'm going to plug back in and just make sure that that other angle is 76. So I'm going to take my x equals 16, and I'm going to plug it back in to the angle 1 equals 5x minus 6, just to make sure that it is in fact 74 degrees. So I have 5 times 16 minus 6 equals angle 1. So 5 times 16 is 80 minus 6. And so angle 1 should equal 74 degrees. So that checks out. So we're good to go. Perpendicular lines intersect to form 4 right angles. We already kind of talked about this. I would make sure you write these symbols in your notes. Make sure to get those jotted down because those are important. You'll see them notated that way on tests, quizzes, homework, the whole 9 yards. If you want to pause and take a minute to read through this and write it down, feel free. So, find x so that line AD and line CE are perpendicular. So they want us to say line AD, so this line straight across here, and line CE straight up and down are perpendicular. So if they're perpendicular, then that means CFD is 90, DFE is 90, AFE is 90, and then AFC is 90. So we know angle AFB plus angle BFC should equal 90 degrees if they're perpendicular, as the problem states. So the next thing I'm going to do is I'm going to sub in 4x for angle AFB. So 4x plus, that was a nice plus sign there. That was high quality. Plus, I'm going to substitute in 5x for angle BFC. 5x. And that's still going to equal 90 degrees. So now I'm going to combine my like terms. So I end up with 9x equals 90 degrees. Divide by 9 to get the x by itself. So I have to do that to the other side as well. And x equals 10 degrees. Or I guess it's not degrees, it's just x equals 10 since it's a equation. So I'm going to look over here and I see that x equals 10 in B. So that has to be my correct answer. Take a minute, read through this, pause the video. I'm going to move on. So pause the video real quick, take notes over the notations, and we're going to keep moving. So determine whether the following statement can be justified from the figure below. Explain that the measure of angle VYT is 90 degrees. So what I would say is, since line XT in red and VY and line VY in green, since those are perpendicular based on this little box here, then I know angle XYV is 90, angle VYT is 90, angle TY question mark is 90. So I can say all of these are 90 because they're perpendicular. Delightful. Determine whether the following statement can be justified from the following figure. Explain angle. Where's my marker? TYW and TYU are supplementary. So right off the bat, I see that they're adjacent angles and that they connect here. When you add the angle measures, they form this straight line, UW. So I can say, without a doubt, they are in fact supplementary based on the fact that they're adjacent with opposite rays, YU and YW. Determine whether the following statement can be justified from the figure below and explain. VYW and TYS are adjacent angles. So if we went back to our definition, we would see that adjacent angles are angles that share a common ray. These angles just share a common vertex. So I would say, nope. it cannot be justified by the definition of adjacent angles. Determine whether the statement measure of angle XAY equals 90 can be assumed from the figure. So looking at this, it looks 90. It does. But I can't say for sure it's 90 because I have no marks showing that it's 90. And I have no marks showing TAS is 90 or SAY is 90 or TAX is Y. TAX is 90. So based on that, I would say no, we cannot assume that they're 90 because this picture might not be drawn accurately or to scale. So we're going to say no. Determine whether angle TAU is complementary to UAY. So, based on the picture, we can say that they're not complementary. And why they're not complementary is because they're in fact supplementary. Ray, that's not the marker I wanted. Ray AT and ray AY are opposite rays, and then the ray AU makes another ray that is shared by the two angles, and so they're adjacent and they are supplementary. They add up to equal 180 degrees. So we would say no yet again. Determine whether the statement angle UAX is adjacent to UXA. I wanted that color. UXA can be assumed by the figure. So we do have a shared ray, but we do not have a shared vertex. So by the definition of adjacent, they are not adjacent. And we also have all these shared points in here, which is also a big no-no for the definition of adjacent. All right, so that concludes our lesson and examples for 1-5 angle relationships. If you have any questions, please feel free to reach out to me via Schoology message or email. We're here for you if you have any questions, but we can't read your minds, which is a good thing. So let me know if you have any questions.